It's just one where du isn't nice. And you have to back substitute in order to, or you have to substitute u squared or u, and then you get a different formula. Okay, what am I doing here? All right, so we're back to numerical approximation. Again, we said that some numerical approximation we've done previously is midpoint rule, left Riemann sum, right Riemann sum, and now we're going to do the trapezoid rule. We talked about the formula T sub n represents the number of subintervals, delta x equals b minus a over n, where a and b are your endpoints and n is your number of subintervals of equal width. And then you have f of the left endpoint, f of the right endpoint, and then 2 times all the inside points, right? All right, so let's estimate the integral from 0 to 1 of e to the x squared by dividing 0, 1 into 2 trapezoids of equal width. Okay, so we're just plugging into the formula, right? First, we need to figure out delta x. Delta x equals b minus a over n. b is 1, a is 0, over 2 trapezoids. So that's b minus a over 2. So that's 1/2. Okay, so my t sub 2, because I'm breaking it into 2 trapezoids, it's delta x, which is 1/2, over 2, times 1 times the left endpoint, f of 0, plus 2 times the inside points, 2 times f of 1/2, plus 1 times the right endpoint. If you want to draw out your interval over here, you can, right? Or you can just say left endpoint plus delta x, plus delta x, plus delta x until you get to the right-hand endpoint. All right? So f of 0, this is my f. I think that was some people's mistake on the first test. This is f of x. Don't integrate it and then plug it in. This is f of x. I'm trying to approximate this, so don't change it. Furthermore, this one you can't integrate. All right, so if I plug 0 in, 0 squared, e to the 0 is 1 plus 2 times e to the 1/4 plus f of 1. Plug 1 in, 1 squared is 1. You get e. All right. So what do you get? Yeah, it's super. I don't think you can simplify this any further, so it's just super ugly. I think I got 1.57158. Something, 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 right? Right, I can't algebraically make this look nicer. Just ugly. All right, so that's the trapezoid rule. Now let's do Simpson's rule. So Simpson's rule is used to approximate the integral, right? My f of x is the function that I'm integrating, where a and b are divided into n subintervals of equal length. So I just copy and pasted this, right, from the previous. N subintervals of equal length, delta x equals b minus a over n. And then Simpson's rule, f sub n, is delta x over 3. And then I have 1 times the endpoints, and then I alternate between 4 and 2, 4 and 2. Something important that I didn't even read, n is even. So it has to be an even number of subintervals, and that's so you can alternate. You have to end in 4, begin and end in 4, and then alternate between 2 and 4 times the inside points. Okay? I did print out from the textbook where Simpson's rule, bless you, Simpson's rule comes from. Let's see. So Simpson's rule, this is a picture of it. This is, if you guys go to grad school for math, This is very similar to something called finite element method, where you're approximating curves so that you can approximate that area. So you're approximating this curve between these 3 points, and you're approximating it with a quadratic function. So that's really smooth. Same thing here, see? I'm saying that this is a quadratic function, guessing, and then that's where you're coming up with that stuff. So let's see. So to ease computations, do you guys want me to read all of this? Do you guys want to know all of this? I think it's good to know. Okay, so we're looking at these points. Let's see. So negative h, 0, h. So you're choosing some x value, and that's what you're calling it. You're approximating it with parabolas. And then these are what you get for your a, b, and c. Right? ax squared plus bx plus c. And you're plugging in your h values into those quadratic functions. And then you're solving for a, b, and c. And then you're writing that out. And once you start to do the algebra, so this is all on page 575, if you guys are interested. So you're approximating it with algebra using a bunch of, or you're approximating it with quadratic functions using a bunch of algebra. Then that's where we're getting the formulas from. That's where you're getting the over 3. That's where you're getting 4 times and 2 times. If you look here. So I can scan this with the notes too, if you guys are interested in looking at it. It's also on your ebook. All right, so this is, so that's the formula for Simpson's rule. You don't have to know where it comes from, but you have to know the formula. But having a little bit more of an understanding, I think, is good. Again, so this is my f of x. So it says, use Simpson's rule to approximate the integral from 0 to 1 of e to the x squared with n equals 6. If I said n equals 5, if I gave you that question on a test, you'd go, not a good question. Moving on, right? So you have to make sure that n is even. All right, so the first thing we need to do is figure out what delta x is. Delta x equals b minus a over n. My a and my b are my endpoints, so I have 1 minus 0 over n. My n is 6, and I get 1/6. So S sub n, Simpson's rule, equals 1 over 6 divided by 3 times. Somebody help me with what those points are. What's f of 0? What's f of x sub 0? Is f of 0. I'm just going to write out the formula with my points first, sorry. And then plus 4 times f of 1/6, right? I'm adding delta x each time until I get to my right endpoint, which is 1. Plus 2 times f of 2 over 6, plus 4 times f of 3 over 6. I could simplify it to 1/2. So 1 times the endpoints, and then alternate between 4 and 2. But it has to be, your first one is 4, and your last one is 4, right? So that's why it has to be even. If it's not even, you're not going to end with a 4. Okay? So 1 over 6 over 3 is what? 1 over 18 plus e to the 0, times e to the 0. Plus 4, e to the 1/6 squared, which is 1 over 36, plus 2, e to the 1/3 squared, which is 1 over 9, plus 4, e to the 1/2 squared, which is 1/4, plus 2, e to the 2 over 3, so 4 over 9, plus 4, okay. Again, super ugly, so I'm going to have to use my calculator to approximate it.
Why does that to end with 4e? Or what's the formula?
That's the formula.
And it has to end like that?
Yeah.
Why?
From the derivation of the formula.
Oh.
But if you don't have an even, number, it would end with a 2, and that's not correct. But it comes from the derivation of the formula.
Since we won't have a calculator on the next test, will we just write it out today and stop?
Seems like we might need one. Huh? I'm sure everybody is. All right, so I did my calculator, 1.46287345. All right, so then last thing we'll just talk about is I made a little approximation summary. If we're ever asked to approximate an integral, the integral from a to b of f of x dx, where a and b are divided into n subintervals of equal length, delta x equals b minus a over n. Here's my subinterval. Here's all the approximation rules we've done. Left Riemann sum, right Riemann sum, midpoint rule, trapezoid rule, Simpson's rule. So if you haven't already made flashcards, here's the summary. Know all these formulas, right? We just added 2 more formulas to these. All right, let's see. Oh, we have 1 more minute. Okay, so we only did 1 example of trapezoid rule, 1 example of Simpson's rule. I think since we already did midpoint, left Riemann sum, right Riemann sum, I don't think we need to spend a lot of time on these computations. The more interesting thing to talk about is the error. So let C be the numerical solution or the approximation. So the numerical solution or approximation, these are how we know how to approximate. So we get that numerical approximation from something above. And X be the analytic solution or exact solution. We get the analytic solution or the exact solution by integrating and doing fundamental theorem of calculus. That's the exact solution. Then the absolute error is C minus X. When you talk about error, it's usually positive. And the relative error is C minus, the absolute value of C minus X over X. All right, and then here's error bounds for midpoint rule, trapezoid rule, Simpson's rule. So we're talking about the maximum error. E sub n is the maximum error for the midpoint rule. Is less than or equal to k times b minus a over 3 over 24n squared, where the absolute value of the second derivative of f is less than k for a less than or equal to x less than or equal to b. So there's different rules for trapezoid, midpoint, and Simpson's rule. They vary just a little bit. My question is, here I'm talking about the second derivative, and for Simpson's rule I'm talking about the fourth derivative. They have to be less than a certain value. How do I figure that out? How do I figure that k value out?
Is it your approximation?
All right, so I want you guys to think about that, and that's what we're going to start with next class. Think about how we find this value of k. I'm trying to look for some value that k is going to be less than, or some value that the derivative is going to be less than.